Good afternoon and welcome to Agri-Food Conversations brought to you by iSelect Fund, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is Tom Bunn, an associate on the iSelect Fund Ventures team, and I'm excited to welcome you all to our discussion today. Agri-Food Conversations is all about driving innovation in ag. Each month we highlight a specific theme, and this month's is nutrient efficiency. On today's call, we are joined by Rick Shang, the CEO of Vulpes Agriculture. Vulpes Agriculture is a chemical manufacturing company based in China that is working on a number of products to address crop nutrition, plant protection, and enable more efficient use of water, nutrients, and inputs. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. You've been invited to this call because you are some of the smartest, most talented people in Vulpes market. You are potential customers for Vulpes products and services. You've built a company similar to Vulpes, or you are a sophisticated business person or ag professional who understands their market and the challenges and opportunities that they will face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. A few process comments while the poll is running. We are not soliciting investment in any way whatsoever. This presentation is to provide information to help Vulpes Ag find customers, mentors, and other strategic relationships that can help them grow their business. Secondly, you are all on mute. However, you can use the chat window to ask a question at any time, and we will have some dedicated Q&A during which you can raise your hand and I can unmute you, or you can type a question into the question pane and I can ask Rick directly for you. Finally, this presentation is being recorded and will be available for replay. So with that, I will hand it over to Rick from Vulpes Agriculture, and he will tell you about what they're doing. Thank you all.
Thank you, Thomas, and thanks everyone for joining me. And before I get started, I want to make a minor correction. We are a company based in registered and also based out of St. Louis. It's owned by Americans. And we do have, previous associations with some Chinese R&D teams, but we are based out of St. Louis. And let's get the journey started. And really, what we do, as Tom mentions, is we're interested in bringing new chemicals into the agricultural world. And for those who know, introducing new chemicals is often a very difficult and also long journey. So I'm very glad that all of you are potentially interested in knowing more about the journey and potentially joining us. And before I get started, there is, in a way, kind of almost an old trope question that we already know. There is almost a surefire way to increase yield. That is by increasing the inputs, by using more water, more nutrients, and everything else. And there is always such a correlation, not easy, but always a correlation between yield and input. But now that we have a growing population, however, we do have a decreasing amount of arable land and decreasing conditions of the environment. The question is really, can we increase the yield without doing what we've always been doing? And the question is it possible to use fewer resources, but bringing up the yield? And I'm hoping through my presentation today, my answer is yes, and it should be a resounding yes. And there are actually many pathways to do that. I do want to say that our insights came from some pharmaceutical well-knowns, and that is some nanomaterials are very good as being drug carriers or drug transporters, and especially carbon nanotube, which is very well known as a useful drug carrier for very precisely targeted deliveries. And our research into the agrochemical world really is based on decades of nanocarbon research. There's a long history that I will not recall, but I would just say, especially since the 21st century, there's a lot of money from federal governments being invested into US research institutions to explore nanocarbon's effect in agriculture. There's a lot of research coming out of University of Arkansas, Duke, University of California, showing that nanocarbon is not only a very effective carrier of nutrients and also water, it is also capable of stimulating plants' root and shoot growth. And this is not just unique to the US federal government or different levels of the governments. We also have a lot of interest from overseas universities and research institutions. There is Indian coalitions, Chinese coalitions, really around the world showing they're interested in doing nanocarbon research. It was only some minor problems. The first is, in the past 20 years, the research was really about the phenomena that they've noticed somehow with nanocarbon plants grow better, resources were transported better, but there's very limited understanding of the underlying mechanism. And then there's another minor problem, which is money. In general, even right now, if you want to acquire the right kind of nanocarbon that works in agriculture, there are suppliers to give you lab quality and lab quantity. And the only minor problem is they're going to charge you $500 to $1,500 per kilo, which really makes research and especially actual real-life trials very difficult. And that's where we came from. We came from a pharmaceutical world to do research, especially manufacturing R&D, on making pharmaceutical chemicals possible. And we came into the picture to bring our expertise into agrochemicals by doing those three things to commercialize nanocarbon in agriculture. And the first thing is really to figure out what the nanocarbons are doing and how they're doing it in plants. And the second is we need to come up with a way to bring down the cost, and we do. We filed a patent to bring down the cost by 99%. And actually it is already a piloted and a scaling manufacturing process. It's not in the lab. We can show you a factory where things are running. And lastly, as I mentioned in one of the last slides, nanomaterial is a touchy issue with EPA and other relevant global agencies. We do have a very clear regulatory pathway to go through the EPA to make the products viable for the first time in agriculture in the US, which I'll come back to. But before I jump into how fanciful our products are, I do want to tell you a little bit about our team. So I am nominally the CEO, but I'm really just the mouth. That I'm here to tell everyone that we are worthwhile and we're doing good things, and please work with us. However, the team is also led by Greg. Greg owned a multi-state manufacturing company. He retired 9 years ago. He retired 9 years ago when he sold his company to Carl Icahn. And I'm very honored that he is kind of getting out of the retirement to join us to manage the manufacturing and logistics side of our company. And I do hope if there are opportunities to build our manufacturing facility in St. Louis. And I'm also joined by Dihu. He has been working in pharmaceutical manufacturing for more than 30 years with an enormous amount of manufacturing innovations, patents, and papers. There's a very tightly held, very nimble team working with him to make the innovation possible. And I am very honored to be joined by those experts while I'm telling you how good we are. Before I dive further, I do want to say that this product is a dual functional product. It is, first of all, a plant growth regulator to stimulate root and shoot growth. And that's where part of the regulatory hurdles will be. At the same time, it is also a very, very effective carrier to absorb water and nutrients from the soil. And then we have research, actually some people's published research to show that then deliver them directly through the seed coats and also into plant cells. This is really due to the complicated nanomaterials, particle size, surface charge, and also other aspects of surface chemistry and physics. And this is not really done by us internally, because the issue with startups very often we claim something and you can't really find it when you try to replicate it. And that's why we work with an entirety of 12 teams coming from 8 research institutions to do very rigorous and extended greenhouse and also field trials. We've been working with them for more than a year, almost 2 years now. Many of them we've already signed a 4-year research collaboration, and we're now trying to get 5 or potentially 5 more both domestic and also international research institutions to join us to expand our list of research collaborations. Now that you know our background, that what we do and the kind of research that we have, I want to show you some research results. The first research result is from our flagship corn research at the University of Florida. And I need to really explain what's going on here. So we are testing corn on 2 kinds of soils. The spotted soil, which is 90% sand, very sandy, very low fertility soil. And the alpha soil, which is a very clay-rich, high productivity soil, very good quality. And we put, of course, corn grown into the soil, and the bright blue bar is the control. It is full fertilization, but 0 usage of our product. And then we vary the dosage of our product by, those are basically showing we're using different dosage and concentrations of product. And what you're seeing here is a dosage-dependent response curve, which is very typical of a PGR. What we're showing is really for the low productive soil, we're showing roughly 300% increase in shoot and root growth. And even in very rich soil, we're showing roughly 20% increase in root and shoot growth. And of course, as you see the arrow bar, they are statistically significant. But of course, our theme today is really about nutrient usage. So this slide is the emphasis of our nutrient uptake change. And again, bright blue bars are control. This really means full fertilization and no use of our product. And we are showing very significant nitrogen, phosphorus, and also potassium uptake increase by having the right dosage. And here the suitable dosage is 200 parts per million of our product. We're showing, again, 300% NPK uptake improvement for sandy soil, which is kind of normal. But even for rich soil, we're showing roughly 30% increase of NPK across the board, broad over the bright bar. And you might say, oh, maybe that's just corn. And I'm very happy to report that we have replication on sugar beet, on tomato, on strawberry. We are showing very similar results. And in this slide, unfortunately, we're only showing P and K because the lab reports us every 2 months, and nitrogen did not make the cut last time. Still, with P and K, we are showing very significant improvement for sandy soil, but also for high fertility soil. We are nevertheless showing 25% of P uptake improvement and 63% K uptake improvement. Well, then you might wonder, why does that matter? What kind of change we are working on? Well, I want to give you some numbers. Based on Purdue University's most recent estimate of cost of agriculture by, I think they made it in March 2020, they're showing for corn production in the US for low fertility soil, which is similar to our spotted soil, farmers are paying on average $119 per acre, which is roughly a third of their eventual revenue per acre from the corn. Of course, in addition to the cost issue, there's always an issue of over-fertilization and fertilizers being kind of basically washed off into water bodies and causing long-term environmental issues. We do have a couple small-scale field trials to show that we can shave off the fertilizer usage by roughly 20 to 30% while maintaining the same yield, parity in yield by using our product. If we're able to show that actually replicated 30% fertilizer saving, then just by corn alone, we're saving roughly $3.5 billion in the US due to 92 million acres of corn being grown annually in the US. we are studying more research on wheat, sorghum, soybean, and also other row crops to see if there are similar effects, and we are positive that there should be. But NPK is not the only kind of resource that we use in agriculture. And I also want to mention the effect of water saving in our turf grass research at UC Riverside's Turf Center, which is a very serious and very probably the biggest turf research center in southwestern and western states of the US. And we want to show you 3 pictures or data. The first is a comparison data here. 1.1 is control. This is just no use of our product. And everything else is just different dosage. As you can see here, we have tried a variety of dosage. And what you can see visually is 30 days after emergence of the turf grass, no matter what the dosage you're using, turf grass grows much thicker and much better. Of course, I want to show you how the water usage is traced in roughly 90 days. Again, blue bar is control. Over roughly 90 days, the control used almost 6 liters of water. But no matter what kind of dosage we're using, our product can lead to a very obvious, visibly obvious reduction of water need. And at the most optimal dosage, which is 400 liters of 0.3% concentration of our product per hectare, we're seeing at best a 35% reduction of water. And of course, we've run the statistical numbers and it is significant. And this is also already presented at the American Society for Horticultural Science annual conference this year with very good feedback. And as you know, water saving is a very major issue across all kinds of crops, and especially when we are going through drought seasons and everything. But here, I just want to focus on turf grass and especially golf courses, because they use a lot of water. And based on the Golf Association's data, just golf courses alone in the US are paying $1.5 billion annually for just water bills. And we're not even talking about environmental and social issues, and including also legal fights for water rights. And in addition to just the bills, drought is a serious issue that's way beyond the issue of just paying the money for water. If we're able to show consistent 10% water saving for golf courses alone, that is $150 million saved in water bill. And if we're saving 30, which is more ideal number, that is $450 million. And we are replicating our numbers this winter. We're doing more extended trials next year. But this is not the end of the story. I did mention that carbon nanoparticles, or our carbon black acid, which is internal product name, is also a very effective plant growth regulator. So I want to give you some example done by 2 separate teams at the University of Florida. And they're facing 2 different problems. The first is they want to help flowers or ornamental plants to grow their roots better and faster. Another team is working on helping corn seedlings to root much faster and better. And I want to give you an example. Here is a comparison of Rex begonia over no treatment using our product and using the industry standard rooting hormone. What we are seeing is doubling the number of roots by week 4, and also almost 50% increase in root lengths by week 8. And in general, by using our product, Rex begonia can hit the market roughly 5 to 7 days earlier than using the standard rooting hormone, which is really leading to 10 to 20% of reduction of rooting time. A separate team is also doing comparison of rooting using the industry standard carbon nanotube, which is really most of the labs are using when they're doing nanomaterial research. And the CNP is our carbon nanoparticle, also known as carbon black acid. They're trying different dosage, different concentrations. What you can see is on day 7, we see very visibly, seriously different rooting improvement. And also, of course, the ornamental data is also presented at the American Society for Horticultural Science. Why does routing matter? Well, there are around 40,000 greenhouses in the US whose exclusive rule is to root. They would root ornamental or specialty crops before they sell the rooted products to downstream nurseries or to growers, which eventually would end up in the customers. And therefore, for them, given their major rule really is rooting, then how long it takes to root is a rate limiting step for their productivity. If we shave off the rooting time by 20%, it is almost a 20% improvement in productivity. But then there's also the issue of working with supply chain and freshness. By making rooting shorter, faster, and more predictable, it would make the supply chain to work much better. And of course, to have the plants in the hands of the customers that would last longer and look fresher. But there's another issue. The issue is the rooting hormone industry has been waiting for disruption for almost 30 years. It really has been using the same set of chemicals since the 90s and without really new chemicals being introduced. And those chemicals really cost a lot. And the wholesale price is fairly visible online. And normally this product called IBA, which is a dominant player in the field, costs you around $20,000 to $35,000 per kilo pure. Of course, people use diluted, but if you buy pure, it is very, very expensive. And we have an enormous price advantage. Because the market really is dominated by IBA and its associated similar oxens, the whole market is $700 million to $1 billion globally without a challenger. And I do think this presents an opportunity. And now that I've talked very briefly about what carbon nanomaterials are and what they do, I do want to tell you something about the regulatory pathway. So for both EPA and also other regulatory agencies around the world, they often have very special regulatory rules for nanomaterial with diameter under 100 nanomaterial. They do have reasons to think under 100 nanometers, those nanomaterials have special nanomaterial effects that need to be regulated specially. However, EPA is extremely reluctant to approve new nanomaterials for uses in agriculture, really because they approved a couple and they will really sue their pants off for a lot of reasons. So they basically don't want to approve anything new. And what is special about us is we have very advanced manufacturing technologies and extensive experience to make sure our products stay right above the cut. Our current average diameter is 130 nanometer with a standard deviation of 30 nanometer, which means we're just slightly above the cut without impacting the performance. And therefore, we are expecting to get exemption from EPA regulation for uses in turf and ornamental before the end of this year. We're almost done with the process. But for food and specialty crop, we need to go through the standard PGL process, which is 2 to 3 years. And we're not working alone. We are happy and honored to be working with two major FDA and EPA law firms in DC, which are Keller and Hackerman, and also Steptoe and Johnson. Now that I've told you something about what we are doing, I do want to tell you our goals for the future. The first is we are looking for beta testers, especially in the turf and ornamental industry. And we want to look for business partners, especially because we have shown that our products work especially well as seed coating or fertilizer coating. And that's why we do want to work with seed or fertilizer company to really co-develop new product lines. Lastly, I do want to say we're not a one product company. Our expertise is really commercializing, especially through manufacturing R&D, to bring innovative ideas in agrochemical into the real world. So we do have actually up to 20 products in our pipeline, and we do want to find opportunities to share with you probably next year or the year after. So this really concludes my presentation, And this is our contact information. Would love to hear your input, your questions, and your comments. Thank you.
Great, Rick. Thank you so much for walking us through your deck. And apologies for misspeaking on the headquarters of the company. So now what we will do is open it up for questions. Looks like we have one already that has come in. As a reminder, you have two options. You can raise your hand and I can unmute you and you can ask Rick directly, or feel free to type a question into the question pane and I will read it aloud. So to start, from Liam Houston, they ask, we have a heavy clay soil with low carbon that we grow lettuce in. It's prone to waterlogging. What results have you had with reducing the impact of waterlogging on crops?
So unfortunately, we don't have a lot of data on lettuce and waterlogging, but I do want to share with you one piece of data that we have. And I don't want to kind of switch around the screen share, the screen shares. I just want to tell you verbally that we've been doing year-long hydroponic growing of lettuce at University of Arizona's I think it's called the Center for Controlled Environment Agriculture for a year now. It's their it's the director of the center doing research for us. And what we are showing, I'm not sure how this directly translates into soil and waterlogging, but what I want to say is we observe across 3 trials, roughly 20% reduction in water usage and transcription rate. And that is fairly consistent from small to large scale hydroponic usage. For soil-based lettuce, I don't have data to tell you, but I would love to discuss if you want to communicate afterwards.
Great, thank you. Rick, wondering kind of what you see as the biggest competitive advantage. I know there are a lot of startups working in this space. How would you carve out your niche, or how would you describe your key niche and competitive advantage?
Thank you. So there are a lot of startups working in the nanomaterial side, and I do think quite a few are doing not the same but similar things with different nanomaterials with similar directions. And we come into the industry from a totally different perspective, that we think about things by manufacturing and regulation. We spend a lot of time to make sure the manufacturing process is scalable. We are already piloting with a very low cost. And we use our expertise to work with the regulatory agencies to make sure there's a viable pathway. But at the same time, we do understand that we do not come from the agricultural side. Although I do need to say some of our team members were literally farmers before they went into college. But that's our only limited connection with the agricultural world. And that's why I'm hoping through iSelect and also through other partners, we might work better with agricultural partners and understand better what partners need for the products to move forward.
Great, thank you. Another question just came in. It asks, does carbon black acid have any impact on how plants respond to pathogens and pests?
Yes, I do want to show you actually one slide that I did not mention, but let me jump back to the slide. So here, as you will see, so this is carbon black acid. This this is just using water. The roots were not even growing very well. The roots are long, but there are very few. So I'm ruling this out. This is carbon black acid, which is roots are growing very well. This is using IBA to root, and we have very thick, but very well nice developed roots. The issue with the standard propagation is there's also always the issue of molding and product loss due to pathogens. As you see, there's kind of a whitening, there's kind of molds here. And in our fairly repeated trials, we see roughly 10 to 20% product loss due to pathogen despite the use of fungicide. But here, in our carbon black acid trials, and we have a lot of trials that I'm not showing you, we've seen 0 case of product loss due to pathogens or molding. And we have a suspicion that carbon black acid is also a very good slow release agent and carrier for fungicide to work more effectively and more durably. So we've also replicated those results, I think, on hop and also on hemp. What we want to do next year is to develop new mixtures of our carbon black acid with different fungicide to see if there's kind of can basically enhance fungicide as a viable product direction. We only have very preliminary results, so I don't want to say too much about it, but we are positive that it might also be a very effective carrier for fungicide.
Terrific. Another question. Could your product be certified as organic?
So this is we really don't know. So the issue was a couple. So this is okay. How do I say this? So we can manufacture this. We already have a proven operational process to manufacture this from agricultural waste and also from food waste, by which we mean corn cobbles and those high fiber agricultural waste. That we have operational process to manufacture stuff from corn cobbles all the way to our product. The issue is there are similar products, at least in theory, similar to us. They struggle to be certified as organic due to the chemical process involved. So the full answer is we don't know. We are trying to be organic and recycle based as possible, but whether we can be certified, we'll basically be waiting till we take a try.
Great, thanks, Rick. So Rick, can you flesh out in a little bit more detail kind of what the next, let's call it 12 months will look like? Where would you like to be in October of 2021?
Yes. So our hope is next year we are going to be working outside the research institutions, but with real greenhouses and real growers, and also real golf courses to do free beta trials of our product on turf and ornamental products for the full year. So we're ready for the official commercial trial launch by September and October for our products in turf and ornamentals. At the same time, next year is also going to be our very big field trial year into the row crops. Row crops normally takes many years, both for trials and for the EPA approval. So we do expect this to be ready in roughly 5 years. During the meantime, we do hope to have actual products on the shelf, or not literally on the shelf, or with our distribution partners by around September or October next year. That's the hope.
Great. Rick, for the last question, I'll pose to you. How can those in attendance and those listening after the fact help you, and who would you like to have reach out to you, and what sort of help can we offer you?
Thank you, Tom. And I really appreciate it. We actually need a lot of help, partially because we don't really understand the thinkings of the agricultural world. We really came from kind of a pharmaceutical background that we want to be introduced to agricultural world. And especially, we are looking for 2 directions. The first is beta testers. Our current focus is on the turf grass and also ornamental industries. Although if you are, or if you know, a row crop or specialty crop grower, we would love to talk as well. And the second really is our product is best used as fertilizer or seed coating ingredients. So it is better if we are able to work with 1 or more seed or fertilizer companies in the US or around the world. We are hoping if there are introductions to their innovation platforms or teams, we would love to have such a conversation.
Great. There was another question that came in, but I think you might have just answered it. It was about formulation and how it is best applied. With that, I'd like to thank everybody in attendance for joining us. As a reminder, we host these every Thursday at 3 p.m. Central. Next month's theme is on sugar reduction. We have a few very good companies lined up to present in November. And again, this presentation is being recorded. And if you know somebody who would like to listen to it after the fact, please encourage them to go to agrifoodconversations.com. They can register and find all of the past AgriFood conversations and get recordings of those. So to those in attendance, thank you very much. Hopefully we will see you soon. To Rick, thank you for walking us through, and best of luck with Vulpes going forward. And please let us know if we can continue to help. Thank you all.
Thank you. Very much appreciated. Thank you.